Okay, so we are welcoming now Moriah Thomason, coming from New York, and who will present some work on fetal motor network integrity and the relation with motor ability.
Thank you. So the central question of our research is, why do some children thrive and others just survive? What are the neural differences that underlie this developmental variation that we see across the human population? And we now know that in many of the psychiatric and neurological disorders of humankind, disruptions in connectivity are an underlying feature. And so the question becomes, how does this arise and where does this happen? And to answer this question, we really need to think about the brain as having a life course. It has a past, it has a future, it has a beginning, it has an end, and that's what we've really been discussing today. And really from the time of conception, that brain is given a connectional diagram. It's given a plan and architecture that it follows. We are programmed. And what's interesting about this programming is that our world writes on it. There is an imprinting of our experiences, even the ways that we are to one another. We influence one another's architectural code. And this programming begins even before we're born. I'm not doing great with the slide transitions. Let's see. Going backwards. Let's go this way. So with the development of resting state technology over the last several years, we now have the opportunity to measure and to model the connectional systems of the human brain prior to birth. And we can begin to answer important questions about both what are the programming events that change the developmental connectivity, and also how do variation in connectivity observed in utero relate to future health and health behaviors. And so to address these questions, we've been following a Detroit-based cohort for the past 7 years. The children were scanned with their mothers prenatally at least one time. We also did studies of MRI studies postnatally and have followed them up behaviorally at 7 months, 3 years, and age 5, and data collection are ongoing. And so as a first question, I want to think with you about the fact that we sort of appreciate that we understand that this connectional organization is already present before birth, as we've discussed today, and probably gives rise to the developmental competencies that emerge during infancy. And yet we have limited information that really tells us whether that developing connectome relates to sort of the individual variation that we observe in childhood. So we performed a study where we looked both at motor system development prenatally and also infant motor development at 7 months using the Baileys. And we also looked at gender differences. Women were recruited during the second trimester, and the study involved 96 fetuses. We performed independent components analysis to isolate the motor system, and then the question that we asked was how connectivity of this system within the system into other regions of the brain varied with motor development. And what you're seeing here are the main effects of that analysis. In blue, these are regions where connectivity predicted future motor behavior. In green, gender effects, and in orange, the overlap. So these are areas that showed both a gender effect and also were related to future behavior. So if we zoom into those orange regions and we ask what is happening in these areas that's different between our male and female infants, what we see is a sharper, steeper slope in our females. So that's the black line depicted here, and the green line is our males. And so what's plotted here is that association of brain connectivity of that region to motor outcomes. So what you're seeing here in this region is that the relationship perhaps is driven by the females. And in fact, we saw that across all of the regions that showed a significant gender and motor effect. So to think about this finding, it's a little bit too soon to draw a conclusion that females are more hardwired, but I do think that it's an interesting possibility that can be followed up with future work. We do know that males are more sensitive to environmental programming, so if it were the case that biology was more prepared with the females to be more robust, let's say, to environmental influences, that would be an interesting effect. So that's something that we can continue to look at. Something that I didn't show you was that we also found that those fetuses that were going to be born to a more challenging postnatal environment also showed stronger prediction of brain to future outcome. And that sort of brings up this interesting idea also about whether the fetal brain knows something about its future environment. And this is something that's worth following up, because even though the environment comes later, many of the things that we know predict a challenging future environment are already present in the prenatal period and are already having an influence on the brain. So that's something I think that we can begin to think more about. So this really leads to the question that I brought up at the beginning of the talk, which is about the programming of that prenatal brain. And I'm very interested in how those interact to potentially change brain networks in utero. And one of the most important topics societally that cuts across economic strata is the role of stress. And we've heard about this. We've thought about how it influences even the course of health during pregnancy and pregnancy-related outcomes. And so here we sought to study this in our sample. We looked at 118 fetuses, again, scanned in the late second and third trimester. And the approach that we took this time was first to measure stress is a complex thing, because there are many different ways to come at it, and quantifying it is challenging. So we performed a factor analysis across multiple different domains to come up with a robust stress factor. We then used a data-driven parcellation strategy to divide the brain into 197 regions, and then used the InfoMap community detection algorithm in order to assign each ROI to a particular brain subnetwork. And then the question became, how does stress relate to within or between network connectivity? We performed an enrichment analysis of these now paired subnetworks of the brain. And what you're looking for here is you're looking at a thresholded matrix where each of these are the significant connections within any given pair. And then we use chi-squared in order to ask whether there are more than would be expected by chance, meaning is there more signal in any of these individual pairs. So the nice thing about this analysis is it still attends to the individual ROI level connectivity differences related to stress, but it's able to summarize whether the signal within two given networks is more than one might expect. We found, indeed, the targets of this stress brain programming were in several different frontal networks to parietal networks, so frontal parietal connectivity, striatal connectivity, temporal insular connectivity to the contralateral hemisphere, and also sensory motor connectivity. And so what I'm showing you here are regions of the fetal brain that were already impacted by stress prior to delivery. Now, these are systems that we know to be disturbed in many different neurological disorders, systems that underlie important cognitive processes. And what we're seeing here for the first time is that already there may be alterations in these networks that are relevant and observable prior to birth. So I want to kind of not leave the conversation by saying, okay, well, now we see that stress influences the brain, because it's kind of hard to know where to go from there. So I work with disadvantaged moms, and we know that the environments that they live in are more challenging. We know that their resources are limited. But what we see in these moms is very resilient outcomes. And it's possible that this is an opportunity, that we could use the information from the brain imaging to say, well, what is the pathway to resilience? How is it that one case can be exposed to stress but have a more favorable outcome, and are those places where potentially we could push the needle? So we wanted to kind of try to understand this, and so the areas that we looked at were social emotional support and health behaviors. So we pulled this additional information that we had in these cases out, and we basically took all of the weights, all of those individual areas that were associated with the stress brain effect, and we kind of, for each individual, tried to come up with a mixture effect. It's weighted quantile sum is the statistical approach that would capture sort of the magnitude of the effect in that brain. So you can imagine if you were all part of the study, I was able to say how much each of you contributed to that overall effect. And then I wanted to look at these other variables and say how they may be modified or modulated the strength of that association. And in fact, we found that there were specific behaviors and engagement in a close personal relationship that did. And what I want to sort of suggest is exciting about this is that these may not be pathways that one would think to intervene. Stress is a hard thing to tackle, but maybe it's possible to look at some of these other areas and then intervene in the effects of the experience on the brain. So the nature of this effect, just so that you know what it was that we found, was that the mothers that had better health behavior, shown in gray, had a stronger brain to stress association. So you can ask, why would that be? Well, I don't think I have the answer, but I do imagine it's possible that in our moms that have less good health overall and higher stress overall, as you can see here, it could be that either those same circuits are already saturated by those health differences, that they're playing on those same systems, or it could alternatively be that the response of the stress system in fact changes when you're under more stress, so that the health is a sort of a stressor. We know from animal studies that the biological responses to stress change when stress is chronic. So those are things we can investigate in the future. So in a final question, we wanted to ask whether the magnitude of this programming predicted how early a child was born. Could it be that the strength of this stress-to-brain effect predicted when a child was born? And in fact, we found that it did. So there was a significant association between how much stress impacted the brain and how early that child was born. And because we know that being born early sets a child at a disadvantage, this child now has two challenges. So in closing, I think that we sort of appreciate that these core competencies are present prior to delivery, that these core systems are present, that they have relevance to the behavior, but we're really only beginning to scratch the surface. And I think that it's very helpful to think about the developing brain as having a learned fit with the environment. I think that that's a perspective that can help us in terms of designing our experiments, and I also really, it speaks to me that we have an opportunity to take the signals from the brain to give us feedback on ways that may help women. So with that, I will close by thanking exceptional research team in Detroit, and I will also thank you for your attention.